This video contains the solutions to take-home problems number 27. For each of these, we need to find the domain, x-intercepts, and y-intercepts of a given rational function. So starting with the domain, we always want to look in the denominator of the function and ask ourselves, when is that denominator equal to 0? Those are the values that we'll have to exclude from our domain. So in this case, we add 1 to both sides, we get x equals 1. So the domain is all real numbers except x equals 1. 1 is the only x value that we are not allowed to plug in. All right, now let's look at the x-intercepts. For the x-intercepts, we're looking where y equals 0. So we're looking at 2x plus 4 divided by x minus 1 equals 0. And we're going to solve this equation by multiplying both sides by x minus 1, which really just has the effect of setting the top of the fraction equal to 0. Add 4 to both sides, divide both sides by 2, we get x equals 2. And since 2 is in the domain, remember the domain is everything except 1, so 2 is in the domain, so the x-intercept is the point 2, 0. For the y-intercept, we just need to look at f of 0. Assuming 0 is in the domain, which it is, we can plug in 0. In this case, we get 4 divided by negative 1, which is negative 4. And so that means that the y-intercept of this function is the point 0, negative 4. So we're going to do the same thing with this function. To find the domain, we set the denominator equal to 0. X squared minus 4x minus 5 equals 0. That's a quadratic equation, so we can do that by factoring. We get x minus 5 times x plus 1 equals 0. That gives us two solutions, x equals 5 and x equals negative 1. And remember, those are the values that are not in the domain. So the domain is all real numbers except x equals 5 and x equals negative 1. Now to find the x-intercepts, we're going to set the top of our fraction equal to 0. X plus 1 equals 0. We get x equals negative 1, but negative 1 isn't in the domain. Remember, we said x equals negative 1 is not in the domain. And so that means that we don't have any x-intercepts. The only thing that could possibly be an x-intercept is x equals negative 1, but that's not in the domain. So the answer here is that we have no x-intercepts. For the y-intercepts, we plug in x equals 0. 0 is in the domain, so we can do that. So we get f of 0, which is going to be 0 plus 1 divided by 0 squared minus 4 times 0 minus 5. That's going to be 1 on the top, negative 5 on the bottom. That's negative 1/5. And so the y-intercept is going to be 0, negative 1/5. Same kind of problem. To find the domain, we set the denominator equal to 0. Here we can just take the cube root of both sides. And that means that we get x equals 0, and so the domain is all real numbers except 0. For the x-intercepts, we set the top of our fraction equal to 0. So we get x squared minus 4 equals 0. That gives us x squared equals 4. Take the square root of both sides, we get plus or minus 2. And since both of those numbers are in the domain, we have two x-intercepts, which would be 2, 0 and negative 2, 0. For the y-intercepts, we want to plug in x equals 0, but we can't, because our domain is all real numbers except 0. F of 0 is undefined, and so that means that we have no y-intercepts. Again, same type of problem. Look at the domain. We set the bottom equal to 0. That gives us x equals negative 1. So the domain is all real numbers except negative 1. For the x-intercepts, we set the top equal to 0. X squared minus x minus 12 equals 0. We can factor that. We get x minus 4 times x plus 3. That gives us two solutions, x equals 4 and x equals negative 3. Both of those numbers are in the domain, so both of those give us x-intercepts, and so our x-intercepts are 4, 0 and negative 3, 0. Finally, for the y-intercept, we want to plug in x equals 0. We can do that here because 0 is in the domain, and so we get f of 0, which is 0 squared minus 0 minus 12 divided by 0 plus 1. That's negative 12 divided by 1, that's just negative 12, and so my y-intercept is 0, negative 12. One last example, going to do it the same way. Start with the domain, set the bottom equal to 0, x plus 3 equals 0, gives us the solution x equals negative 3, so the domain is all real numbers except negative 3. For the x-intercept, we set the top equal to 0, x squared minus x minus 12, we just did this one, so we know that that factors as x minus 4 times x plus 3. That gives us two solutions, x equals 4 and x equals negative 3. But this time, we're not allowed to plug negative 3 into this function, because the function would be undefined, so we have to take this solution and throw it away. And so this time we only get one x-intercept, which is the point 4, 0. And then finally for the y-intercept, we want to plug in x equals 0. We can do that here. 0 is in the domain, so we get f of 0 equals 0 squared minus 0 minus 12, all divided by 0 plus 3. That's negative 12 divided by 3, that's minus 4. And so the y-intercept is 0, negative 4. So that's it.